Okay, welcome back. I'm now going to continue my last topic of integration with partial fractions. And I'm going to talk about, I guess this will be example 3 if we're continuing from the last video. So the first video I covered decomposition of partial fractions with linear factors. And by that I mean an x minus 2 or 3x plus 1 or 1 minus x. These are all linear factors because the power of x is exactly 1. Okay, so now I'm going to talk about what do you do if you have a non-linear factor and in the denominator. So if you notice in this integral here, this little x squared plus 1 is a non-linear factor, and we cannot factor it any further. So we can't reduce this x squared to the product of two linear factors like we would hope. So I'm going to talk about what happens in this scenario. So the first thing that we're going to do is we're going to try and decompose this fraction. So if you recall, this fraction could be thought of as the sum of something over the first factor plus something over this factor plus something over this factor squared. Now notice I'm including this factor twice because it is a squared term. So since the term is squared, we have to include possibilities for this thing to the first power and this thing to the second power, just in case. They're both options. Now on top, because this is an x squared term, instead of just having a constant up here, what we're going to have is potentially an x term plus a constant. And the same thing would be true for this one. So it just got a lot more complicated, right? Instead of having 3 constants like we would, now we have 5 constants that we have to find. So the next thing that I'm going to do just like we would do in the first 2 examples, is multiply absolutely everything by the total denominator. So that's going to cancel out this on the left, and we'll just be left with this numerator. That's going to equal a times x squared plus 1 squared plus bx plus c times x squared plus 1 plus dx plus e times x. Okay, so this step should be the same as last time. Nothing really changed. Okay, and then once we have all the denominators gone, as we do in this line here, we should remember that this giant equation that I have written should hold true for all values of x. So what we're going to do is we're going to pick some values of x to try and see if we can find out what is a, what is b, what is c, what is d, and what is e? Okay, so I'm gonna kind of keep tabs over here if I can. So let's start trying some values of x. I'm going to try x equals 0 first, because what that's going to do is eliminate all of the constants except for a. So that's great news for us. Okay, so we're going to get 1 is equal to a times 1 plus bx plus c times 0 plus dx plus e times 0. Okay, so these terms are gone, right? Anything times 0 is equal to 0. So really, we already know a is equal to 1. Okay, so we've already tried x equals 0, and unfortunately, that's the only good one that we can try that's going to eliminate some of our constants, allowing us to easily find the other ones. So at this point, I would just start trying basically random values of x, but we'll use small numbers because that's easier. Another thing that I'm going to do really quick that I don't think I did in the first two examples, but now that we know a is equal to 1, I'm just going to put 1 here where a was. And 1 times anything doesn't really change the values, so that kind of makes our life a little bit easier. Anyways, I'm going to try x equals 1 and see what happens. Likely because we have 4 constants remaining, we may have to set up a system of equations. But we'll see what happens. Okay, so if we plug in x equals 1, we're going to get 1 minus 1 plus 2 minus 1 is equal to 2 squared plus bx. Oh, no, not bx. Just b times 1 plus c times 1 times 2 plus d times 1 plus e times 1. Okay, so this looks quite complicated, but I think it's going to simplify to something nice. On the left hand side you get 1 equals 4 plus 2 times b plus c plus 1 times d plus e. Now if we subtract 4, you get negative 3 equals 2b plus 2c plus d plus e. Okay. So we were unable to eliminate any of our variables by plugging in x equals 1. That's pretty much what I expected, and that's okay. Not a big deal. Okay, so we're going to try maybe x equals 2. No, why don't we try x equals negative 1? I think that might be better. Okay, so we're going to get 1, well, on the left hand side we're going to get 1 minus negative 1 plus 2 minus negative 1 again is equal to 2 squared plus b negative 1 plus c times negative 1 times 2 plus d times negative 1 plus e times negative 1. Okay, so we have a lot of negative 1s here, so we got to be real careful about our negative signs. 1 minus negative 1 is 2, plus 2 is 4, minus another negative 1 is 5, is equal to 4 plus, I think this is going to be c and negative b, so c minus b times negative 2 plus e minus d times negative 1. And that is going to give us 1 is equal to negative 2c plus 2b minus e plus d. Okay, we have another system of, we have another equation where we have failed to eliminate any of our constants. Tough luck, right? So it's starting to look like if we cannot eliminate any of our variables or any of our constants here, in order to solve a system of equations with 4 variables, we're going to need to come up with 4 equations relating them to one another. So we should probably try x equals 2 and see what happens. I'm actually going to rewrite these 2 equations somewhere else on the screen if I can find some room, because I kind of need that area to work with. So I'm going to put them here in the curly brackets. So we get 1 equals, I'm also going to write these in order, with the letters in order, so we get 2b minus 2c plus d minus e. And negative 3 equals 2b plus 2c plus d plus e. Okay. So we're going to try x equals 2 and see if we can come up with another equation relating b, c, d, and e to one another. Okay, so 1 minus 2 plus 8 minus 8 is equal to 5 squared plus 2b plus c times 2 times 5 plus 2d plus e times 2. Okay, these go away. 1 minus 2 is negative 1 equals 25 plus 20b plus 10c plus 4d plus 2e. Subtract 25 and you get negative 26 equals all of that. So I'm just going to go up here and write this. Negative 26 equals 20b 10c 4d 2e. Okay, and I think for the last value, right, when you 4 equations up here, because we have 4 unknown quantities, I think I'm just going to try x equals 3. I was thinking about trying x equals -2, but I just didn't like dealing with all the negatives. So I'm just going to try 3, and we'll just deal with the larger numbers. Like I mentioned before, this equation here should stand true for all values of x. So really, you could pick anything you want. You could pick 100 if you want to deal with really big numbers, but I'm just going to stick to the smallest possible integers. Okay, so 1 minus 3 plus 18 minus 27 equals 10 squared plus 3b plus c times 3 times 10 plus 3d plus e times 3. I believe this is going to be -11 is equal to 100 plus 90b plus 30c plus 9d plus 3e. And then if we subtract 100, we'll get minus 111. Okay, so now we have our 4 equations. So that means we should be able to solve for our 4 unknown constants. We had 5, but a was equal to 1, and it was pretty easy to eliminate that. Okay, so if you have a system of equations like this one here, I highly recommend using a matrix method. So you'll need probably a TI-83 or a TI-84 or some kind of graphing calculator. And basically what you want to do is into matrix A or something comparable, you want to put your coefficients for, oh wow, coefficients, not letters. Okay, so this is going to be a 1, -1, if you already know how to solve a system of equations like this, then you can just pretty much ignore everything I'm saying. And if you don't, this might not help very much, because I'm not going to go through all the steps. But hopefully if you've done this before and you have some idea of what's going on, then maybe this will kind of spark your memory. Okay, so you need all of your variable coefficients in matrix A. And you need all of your answers, or what they're equal to, in matrix B. And then to find out what is B, what is C, what is D, what is E, once you have this, you basically take matrix A inverse and you multiply that by B. And your answer basically should tell you coefficient B, coefficient C, D, and E in that order. Okay, and then once you do all of that, yeah, I'll go ahead and erase this. You should get something like this. negative 1, 1, and 0. Okay, so that's a little anticlimactic, but that means B is negative 1, C is negative 1, D is 1, and E does not exist. It's not there. So, our original integral, oh yeah, I'm going to erase some of this too. No, we don't really need it anymore. So our original integral can now be written as the sum of three pieces. So we get 1 over x times dx plus integral negative 1 over, oh, actually that's going to be negative x minus 1 over x squared plus 1 plus 1x over x squared plus 1 squared. Okay, now actually we could probably gonna need to separate this middle piece into two pieces again. So this is going to turn into the negative integral x over x squared plus 1 minus the integral 1 over x squared plus 1. And these should both have a dx. And then we have this one. And then we have this one. Okay, so let's start working on these four integrals here. Well, this first one's pretty easy. It just becomes the ln absolute value x. The second one is a little harder. So actually, maybe I should write this a little bit lower. Some of these will have to do some work. Okay, so for this middle one, or for the second one, we'll have to do a u substitution. And so we'll let u equal x squared plus 1. That means du is going to be 2x times dx. And that means x dx is going to be 1/2 times du, which means this integral becomes negative 1/2 integral du divided by u, which is negative 1/2 times the ln of absolute value of u. So that's going to be minus 1/2 ln absolute value x squared plus 1. No big deal, right? Okay, this next piece is kind of weird. This one right here. And I'm not going to go over the explanation for this because it's probably on a chart. Like if you have a chart of integrals somewhere, you should look at it and see if you can find an integral of this form. Basically, it's going to be minus because there's a minus out here, but inverse tangent of x. Maybe I'll make another video of showing why that works. Oh, I already did. This is trigonometric substitution. So if you don't understand why this piece is equal to inverse tangent, go look at the video. I think it's just called Integration with Trigonometric Substitution. So if you're unclear on that, just check it out. And then this next one, this fourth piece, is also going to be a u substitution. u is going to be x squared plus 1 again. So this is going to work out in a similar fashion, except for 1 over u. Now we have u squared, which is u negative 2. So this is going to work out just to be negative u to the negative 1. So this is going to be negative 1 over x squared plus 1. Oh, I lied a little bit. There should be a 1/2 out here. I'm so sorry. 1/2. And this should be negative 1/2. Okay, so there's going to be a 2 right there. And then plus an arbitrary constant, which I will call c. And finally, this is the answer. Okay, so I'm just going to briefly talk about the decomposition of the fraction, that aspect of the integral, which is actually just an algebra trick. It was probably covered in a Algebra 2 class, or maybe a pre-cal or trigonometry class, something like that. So they don't really go into a lot of detail on this topic in Calculus 2. They just assume that you know how to do it. So if you're uncertain on how to decompose fractions, you might want to crack open a algebra textbook of some sort, possibly a pre-cal textbook, or even, I know Khan Academy has some videos, and I'm sure one of their videos covers decomposition of fractions, and so you should be able to figure out that aspect of it. Basically, I'm not going to solve this, I'm just going to talk about it. So we have an x squared here, x squared plus 1 cubed here. You have to remember that for this one, there is a multiplicity of 2 here, there's a multiplicity of 3 here, so that means we're going to have up to 5 partial fractions on the right hand side of our equals. Right? This could be something over x plus something over x squared plus something over x squared plus 1. And then I'm going to remind you that because this is not a linear factor or the product of some linear factor, in other words, we have an irreducible x squared term, this has to be some coefficient with x plus a constant. And this is going to be something over x squared plus 1 squared. So this might be ex plus f. And then because we had a multiplicity of 3, this might also include x squared plus 1 cubed. And this might be gx plus h. So you can see as we start to add these non-linear, irreducible quadratic terms, it just gets more and more and more complicated. I hope you don't have to do an integral involving, what is this, 8 constants. I hope that doesn't happen. But if it does, you can basically just remember the steps for partial fraction decomposition. If you can't remember, check it out on Khan Academy, check it out in an algebra textbook, and that should refresh your memory. I guess that's all I have to say about it, so I'll see you in the next video.